Hello everyone, this is an update and on some of the projects I've been working on, and today I will be talking about a tower defense game that I recently started. It's built from scratch, it doesn't use any pre-existing engine, and I'm making it first for Linux and then later I will port it to other operating systems. But there is a lot of things to take into account there, to how to bundle libraries and also make sure that all the licenses are compatible and such things. But I'm saving those things to a bit later, and now I'm trying to focus on making the basic game engine and try some things with the game. I don't want to go into much detail of the specifics of the tower defense yet, but I do have some plans that I think are quite different from what is already in other popular tower defense games, and I want to try this out and see if this will be a cool game. So in this update I will go into some technical challenges in making this game and maybe show a trick or two that I've learned on the way. I wanted to have an hexagonal grid. So here we have a grid, and if we triangulate this grid we get something that we can turn into an hexagonal grid. If we look at this from the top here, what we need to do is that we first rotate it 45 degrees. So we have triangulated it and rotated it, but we need to also apply this triangulation in order to edit this. So let's apply that one, and now we have the actual triangles here. If we look at an hexagon here, we see that it's not very round. But we can solve this by adjusting the X position to something like this. Now these hexagonals looks much more round. And when we are creating this grid, we're not going to do it as I showed here in Blender. We're going to directly create the vertices of it. So we'll create one line of vertices and then have the next one that is offset by half, because this one goes just to the middle of this one. And then we just need to get the height right, because the height here is not 1. It's actually cosine of 60, I believe. Because if we put it in a circle here, then we have 60 degrees here, and we want to get to this y coordinate here at this coordinate. Like this one will be 1, so this one will be, I think, cos 60. Let's verify that. It could be sine also. But cosinus takes radians, so if we multiply it by tau and divide it by 360, we get 0.5. So that's wrong. Then it was probably sine. Okay, it was sinus. So sine 0.866. Let's verify that just to be safe. Let's see if we make a circle that is on this point, and then we just check the properties of this circle. Placed. Oh yeah, 86.6025. And we can see that 86025. Yes, so that is the correct expression for creating this grid. I was thinking about the draw order of this, and I was thinking maybe I could use draw strip. And in draw strip it will always make a triangle from the 3 last vertices. So if you add 3 vertices you get 1 triangle, and then for each vertex you add you get a new one. So I thought maybe I could draw it like this in just one draw call, but that turned out to not be the case, because if you draw it like this, zigzag, you get a nice strip, but you can't get around to the other side. So I had to instead draw it as multiple strips, and I'm going to investigate how I can instance that in OpenGL. But for now, it's just I've decided to just store it as triangles instead. So it has a vertex buffer with all the vertices, and then a face buffer with all the triangles in it. And that's a bit wasteful of memory, but for now that was an easy way to get the terrain going. So here is a height map that I found on the internet. So it's not my work with the height map, but this is my software that draws it as I described before with the triangulation. And this seems to be working fairly well, so I'm going to use it like this for now. I've also been experimenting with the freetype and font maps to make texture atlases, and this may not say that much, but here it has created an atlas on a 2048 by 2048 texture, and we can have a look at that one actually. So we open it as raw image data, and this is a gray scale 8-bit and 2048 by 2048. So here we can see how the glyphs have been packed in this texture map, and they get packed by their height. So here we have some fin glyphs like the double quotation mark and equals. Here we have dash and underline. I guess it's called hyphen. Dot gets its own row here. Here are a few that didn't render, they rendered, but they rendered as little boxes. And I'm going to use fallback fonts for certain things also, so I'll probably be using more than one font. Here you can see these that have the same height. So they are packed by height now. And this works well, I think. So this is how I'm going to deal with textures and glyphs and font rendering in the game. So it will automatically create a texture atlas on a need-to basis. And the algorithm that I've made for making this texture, it will, like, if this line is full and there are no other lines that has the right dimensions, it will use one with close dimensions. Like, of course it will not use one that it can't fit in, but it will try to find a bigger one in that case. So now it hasn't utilized this texture very well, but I could make it much smaller and it would utilize it better. So this is just some testing that I'm doing. I also had some interesting encounters in the GNU debugger, GDB. So here we have, this was just something I found that was helpful. I found that if you launch GDB with -TUI, like in terminal UI, you get a split screen where you get the sources and you get the normal debug window under here, which can be nice. Though I do prefer to browse my sources in a graphical text editor. I did have an issue where I had this function that would define a constant string, and I was hoping it would always end up in the object file like a constant, but it only does that if you define it right in a translation unit, if you define something constant there. But if you define it inside of a function, for instance, then it will instead end up on the stack, as can be seen here, where I execute info-proc mappings in GDB, and we can see that the address of the source file name here that I used this expression here to define, it ends up here on the stack, and I wanted it to end up here in the object file instead. So it seems like I solved it by declaring it as a static expression inside of this this expression. This is what is this called? When you use the parentheses before the curly braces, you get a specific expression type macro where it will take the last entry of the function body and return. And this is very useful if you want to avoid to do double execution or double evaluation of an expression that you feed into the macro, because you can then declare it as a temporary variable inside here and only evaluate it once and then return that variable. And that's not really what I'm doing right here, but that is one very useful feature of it. But here I declare a local variable that is static, and then I return that. So then it makes sure that it ends up in the BSS segment at least, rather than on the stack. Right now I'm not working on making this very portable at all. I am trying to make sure that things are modular enough so that when I'm porting it to another operating system that it won't be too bad. But as in early development, I'm just making it run here on my local computer. So initially this will only be working on Arch Linux probably. There is also a bit tricky with how I'm going to deal with libraries, because some libraries, I use a few different libraries, and these libraries sometimes build on other libraries, and I have to, like, they use these automatic configuration tools that I'm not familiar with, that often configure them to use system libraries where I want to make sure that everything is bundled together, that I have that I don't depend on system libraries too much, because that could make it much harder to make it portable. But these are things that I'm going to look into more deeply when I'm getting closer to actually trying to port it to other operating systems, and I'll deal with those issues then. I got the PNG library working the way I wanted it, and here I'm just showing it in a terminal to make sure that it works. Testing freetype a bit, and here I'm drawing one of the emojis that's in the no to color emoji font. The last bit I did was working a bit with glfw, and here we can see the output that it shows also the libraries it's using, because I keep track of libraries in order to present errors in a good way. And here is one error, for instance, when it's compiling the fragment shader, because on purpose I have an error in the shader just to make sure that I'm catching errors, because I've been working a lot on the error handling of this. And the way I do handle errors is that I have log entries with a timestamp, source file name and line number, what library was responsible for this error, more information that can have name, description, code, and also some flags in to deal with cleaning up, like if this is pointing to constant memory or if it's pointing to memory that I've allocated and should therefore deallocate, and some functions to dump the log to a file. I'm using a ring buffer for the log, so so here is the ring buffer where I have the log entries, and I have a head and a tail, so I will write to the head and read from the tail, and if the head ever catches up to the tail, then I had the overflow, and I will set the overflow flag, and I will remove the last entry, so I'll overwrite the tail and move the tail forward, and this way I can always catch the last X log entries, and I'll set X when I initialize the error log. So when you call error log in it, you give it a log size and we'll allocate memory for that. And the good thing with the ring buffer is that you don't have to worry of it being full. Like, sure, it's bad if it gets full because you lose information, but if you have an error that happens, like 10 times every frame or something, you don't want to allocate memory or print that out indefinitely. That's also a thing that I have here. I have a repeat count. It only works for things that are repeated consecutively. So if you have 2 errors that happens, error 1, error 2, error 1, 2, 1, 2, 1, 2, then it won't work. But if it's just error 1, 1, 1, 1, 1 all the time, it will increase the repeat counter rather than adding a new entry. So this is also a good way to catch the problem when you sometimes have an error that happens every frame you're rendering, and you're rendering 60 frames per second, and you get 60 errors per second. Then you have, like, if the error log is 64 entries, you have lost entire log in 1 second, and that's not good.